Hello everyone. Today again we will look at another case study. This time we will look something on the Aditya L1 mission launch. So all of us know that it has been successfully launched. Now let us look at a case study of what was the objective of Aditya L1 mission and what were the payloads that it has carried during this mission. The objective of this L1 mission is to study the upper atmospheric dynamics. It includes the chromosphere and the corona. To study the chromospheric and the coronal heating, physics of the partially ionized plasma, initiation of the coronal mass ejections, and the flares of the sun. It was also done to observe the in situ particle and the plasma environment, providing data for the study of particle dynamics for the sun. Also, the physics of the solar corona and the heating mechanism was also being tested. Another objective was to carry out the diagnostics of the coronal and the coronal loops plasmas as temperature, velocity, and density. Then the development of dynamics and the origin of CMEs um, to identify the sequence of processes that occur at multiple layers, the chromosphere, base, and the extended corona, which eventually leads to the solar eruptive events. To study the magnetic field topology and the magnetic field measurements in solar corona. To understand the drivers for space weather, origin, composition, and the dynamics of the solar wind. Now, what is the uniqueness of this solar machine? It is the first time spatially resolved solar disk in the near ultraviolet band. Coronal mass ejection, that is what the CME is. Coronal mass ejection dynamics close to the solar disk, that is from about 1.05 solar radius, thereby providing information on the acceleration regime of the CME, which is not observed consistently. Onboard intelligence and to detect the CMEs and the solar flares for optimized observations and data volume. Direct and energy anisotropy of solar wind with using multi-directional observations. So let's move on. Aditya L1 mission payloads are seven. All of us know that it is around seven payloads, and all the payloads have been, we have listed down here. Has been developed by various institutions inside the country with the collaboration of ISRO. The first one is a visible emission line coronagraph, or VELC. It studies the solar corona and the dynamics of coronal mass ejections. It was developed at the Indian Institute of Astrophysics in Bangalore. The Solar Ultraviolet Imaging Telescope, it images the solar photosphere and the chromosphere in near ultraviolet or UV, and also measures the irradiance variations, solar radiance variations in near ultraviolet. This instrument, or it's called as a suit, was developed at the Inter-University Center for Astronomy and Astrophysics, Pune. This is a larger picture where you see the telescope being shown in with various parts. The third one is the Aditya Solar Wind Particle Experiment, or aspects. Now, it is there are two things. The PAPA as well as the aspects. The aspects instrument was developed at the Physical Research Laboratory, Ahmedabad, and the next one, that is the plasma analyzer package for Aditya, uh, is which is also studies the energy distribution, etc., was developed by Vikram Sarabhai Space Center at Trivandrum. These are designed to understand the solar winds and its composition and do mass analysis. The solar low energy X-ray spectrometer studies the X-ray flares from the sun over a wide X-ray range in an X-ray energy range. It was developed at the UR Satellite Center, Bangalore. We see it here for SOLEEXS. The high energy L1 orbital X-ray spectrometer or Helios or HEL1OS, like Helios, it is pronounced that. The It studied the X-ray flares from the sun over a wide X-ray range, energy range. It was developed again at the UR Satellite Center, Bangalore. The seventh payload, or the magnetometer, is capable of measuring an interplanetary magnetic fields at the L1 point. And the magnetometer payload was developed at the Laboratory of Electro-Optic Systems at Bangalore. We see here the PAPA and the SUIT is here, the VELC is here, SWIS is here, the Helios, etc. All these are the 7 payloads. Now, the payloads can be divided into two. One is remote sensing payloads, the VELC, the SUIT, and the SOLEX, as well as the Helios. They are all remote sensing payloads. And you have the in situ payloads, or the aspects, PAPA, and the high resolution digital magnetometers, right? So this one is the kind of um, various uh, payloads that the Aditya has been launched, and yeah, let's do the conclusion. The orbit of the Aditya L1 was set in the Sun's Earth systems L1, where the gravitational pull of both the bodies is balanced out. That is what we have been talking about. This was very successfully launched at Sriharikota Spaceport on the September 2nd at 11:50 a.m. and we had the privilege of seeing the telecast live in our own campus. And we are proud that the of this mission, and we also went to find out what is the present status of Aditya L1. Aditya L1 is on the Lagrange point 1, and according to the live website, which is given at by ISRO, okay, the Aditya L1 has achieved success in completing the first earthbound maneuver. Now, having gone to the website of Aditya L1, we also of ISRO Department of Space, we find that for the Aditya L1 machine, these are the updates that have been given. As and when uh, the the mission is progressing, they are releasing such kind of information to the public. Now, September 30th, they have done 20, that they have reported that the spacecraft has escaped the sphere of Earth influence and is on its way to the Sun-Earth Lagrange point. Now, October 8th, they have reported that a trajectory correction maneuver was carried out, which was already planned, but it was carried out. It was needed to correct the trajectory evaluated after tracking the trans-Lagrangian point L1 insertion, that is TL1, and the maneuver was performed on September 19th, 2023. The TCL ensures that the spacecraft is on its intended path towards the halo orbit insertion around the L1. Now, students should understand that these kind of small corrections, etc., will be done on the trajectory, and how they, why that happens, and how they are brought back to the original orbit. Now, the last that has been received is on November 7th, where the Helios, it is one of the payload that we have been talking about. It captures the first high energy X-ray glimpse of the solar flares. Now, solar flares are there on the sun's Earth. We have already seen, know that, and such flares have been, the image has been captured and has been sent. Now, we in this case study, we looked at the launch of the Aditya L1 mission successfully. We also came to know about the L1 point, or the Lagrangian point, which is a balance between the a balance point where there is no kind of a equal push or bit push or pull between the Earth as well as the Sun, and it is a point or a small circle around which this is orbit around which this is going to hover around. Now, being there, we also found and discussed that the various payload that this mission is carrying. Now, this is one of the first one such case study that we are trying to talk about. That is the 7 various payloads and where they have been manufactured with the joint venture with which department of the ISRO. All that has been discussed, and then we have ensured that we give you the maximum information on this particular thing, the required informations. Okay, so moving on, these are the references that I have taken, referred these websites. The ISRO websites will keep updating ourselves. It's been wonderful, that and heartwarming to know that the mission is doing well, and we feel proud as an Indian. Um, we will meet once again on another case study in the in the next episode. Till then, it's bye from Dr. Emil Langovan. Thank you very much.